Hello everyone and welcome back to the channel. Today is Tuesday, May 12, 2026, and I am your host, Mino. I hope you are having a wonderful day so far. Today I am introducing a trending article from the archives. It is an absolutely fascinating piece of research. I love sitting here in my little radio booth, talking to myself and to all of you out there. It really is a fun atmosphere. Before we dive into the science, let me ask you a question. Why did the artificial intelligence cross the road? To optimize its parameter trajectory across the asphalt baseline. Hello? I guess I'm the only one laughing at that. Anyway, let us get into the real reason we are here today. The title is LLMs Improving LLMs Agility Discovery for Test Time Scaling. The colors. Schatzkalksivord ABS 2605 8083. It is quite a long title, but it packs a serious punch. Let us dig deep into what this paper is actually talking about. Right now in the world of artificial intelligence, we have this concept called test time scaling. Basically, this means that when you ask a language model a question, you give it extra time and computation to think before it answers. It is like giving a student an extra hour on a math test. If they can work through the problem multiple times, they will probably get a better grade. But there is a huge problem with how we currently do this. Up until now, the rules for how the model should spend extra thinking time were made by humans. Researchers sit down and manually design rules for when the model should branch out into different thoughts, when it should think deeper about a specific thought, and when it should just stop thinking and give the answer. This is called handcrafting strategies. The problem is that human intuition is limited. We cannot possibly imagine every single best way for a computer to think, so the researchers behind this paper proposed something brilliant. They asked, what if we stopped designing the thinking rules ourselves? Instead, we design an environment and an AI agent can discover the best rules automatically. They created a framework called AutoTTS. In this framework, an Explorer language model acts as an agent. This agent looks at different ways of allocating computation, evaluates them in a simulated offline environment, and figures out the best strategy by itself. Or it is like hiring a manager to organize your factory, instead of trying to micromanage every single worker yourself. To make this search process affordable, they used offline replay. This means they pre-collected a bunch of reasoning paths, so the agent does not have to waste expensive computing power to text every single time it tests a new rule. They also use something called Bayes parameterization. This forces an agent to use just one main knob to control how aggressive or conservative the thinking process, which prevents the agent from creating overly complicated and useless rules. Let us compare this with other technologies. Traditionally, methods like self-consistency just generate 64 different answers, and then pick the most common one. That wastes a lot of computing power. Other methods try to stop early if the first few answers agree, but they are still based on rigid human logic. BDATS is completely different because the rules themselves are discovered by the machine. The discovered strategy learns how to check momentum, meaning it only stops thinking when the confidence in the answer is not only high, but consistently high over time. It completely changes the game by achieving better accuracy while using 69% fewer tokens. Now you might be wondering how this applies to everyday life. I have 3 specific application examples for you. First, think about automated medical diagnosis systems. If a patient inputs symptoms into an AI doctor, some cases are simple like a common cold, but others are complex and rare. Using the technology from this paper, the AI could automatically allocate very little computing power to the obvious cold symptoms and aggressively branch out and think deeply about the complex cases. This ensures patients get highly accurate advice without the hospital wasting millions of dollars on computing costs for simple questions. Second, let us consider the legal field and contract analysis. Lawyers use AI to read massive contracts. Without cuts, the software could quickly skim the standard boilerplate clauses. But when it detects a strange or highly customized clause, it would dynamically generate multiple reasoning branches to analyze the legal risks. It would know exactly when to keep digging and when to stop, making legal services much faster and far more reliable for the average person. Third, imagine real-time language translation devices for travelers. When you are ordering coffee in a foreign country, the translation needs to be instant. But if you are discussing nuanced business deal, you need perfect accuracy. A translation device powered by this automatic scaling strategy could adjust its thinking time based on the complexity of the conversation. It would give you an instant translation for simple words that take a split second longer to accurately translate a complicated cultural idiom, but would make cross-cultural communication so much smoother. It is amazing to think about how shifting the human role from designing animals to designing environments can lead to such massive breakthroughs. The researchers discovered that their agent could find better strategies in just 160 minutes, costing only $39. That is the price of a nice dinner. And it unlocked a whole new level of efficiency for large language models. This really makes you wonder what else AI could optimize if we just give it the right environment to play in. Thank you so much for tuning in to my little radio show today. I always enjoy breaking down these complex topics and sharing them with you. Have a wonderful rest of your Tuesday, and keep your curiosity alive.